The chemistry behind fear and anxiety. Fear is an important mechanism that has ensured the survival of the human species. But in the modern world, this chemical reaction often harms man more than it does good. In this article we will talk about the chemistry behind fear to explain what happens from the initial trigger to the increase of T cells in the body. With the ever-increasing prevalence of anxiety and fear, it is more important than ever to know what it entails so that you can take appropriate measures to prevent it. Knowing what it entails can help you and the people around you avoid catastrophic thoughts and other common symptoms of anxiety. Is fear a bad thing? Many experts consider stress, fear and anxiety to be one and the same thing. However, one seems to be more stigmatizing in our modern society. They are both related to the body's stressor response, which is a natural biological process that is necessary for human survival. You shouldn't see anxiety as just good or bad. When an impending threat causes the person to become fearful or anxious, the fight or flight response often kicks in. The human species has evolved with this mechanism because it has ensured our survival. Without it, we would not be able to act quickly and make quick decisions on the spot. Our body would not have the physical ability to protect us. The problem occurs when the body triggers the stressor response to danger where there is none. The body thus prepares to fight or flee even though this reaction is completely unnecessary. The chemical and emotional response involved in fight or flight is what makes you feel so weird when you're anxious. The chemistry behind fear. Threat evaluation. Fight or flight. When we identify a threat, we evaluate the situation within seconds. Although humans are not often chased by lions, the reaction is the same to anything that feels like a threat. It can be anything from a simple comment to a strange sound that feels threatening. The sympathetic nervous system in the chemistry behind fear. When a threat is assessed, the body's chemistry kicks in. In the sympathetic nervous system, the hypothalamus pituitary adrenal axis is activated, which then triggers the release of adrenocorticotropic hormone, ACTH. The hypothalamus regulates how much ACTH is released in the body. It is also responsible for regulating when we eat, drink, mate and be aggressive. Thus, it makes sense that the neurohormonal mechanisms of the stressor response are also triggered and stimulate the pituitary gland to release ACTH. On the other hand, ACTH stimulates the adrenal glands, which then flood the bloodstream with glucocorticoids. Glucocorticoids help during stress. Glucocorticoids allow us to survive stressful situations. It involves everything from physical injuries, such as a broken leg or falling from a tree, to situations involving fear, anxiety and hunger. The glucocorticoids stimulate adrenaline and endogenous peptides. The latter, involved in homeostasis, maintenance of the body's balance, pain regulation, cardiovascular control and stress. The release of adrenaline and other hormones pauses certain body functions that could be harmful in stressful situations. Digestion, for example, requires a lot of energy. This is why you can get an upset stomach or lose your appetite after an anxiety attack. Just be patient and let the body recover. The body releases peptides to help you better endure pain from any injury. The consequence of the chemistry behind fear. This hormonal activity creates a lot of changes in the body, and not just the ones you might expect. The stressor response causes many internal changes, which are not always noticeable. Some of the techniques psychologists use to reduce the stressor response are controlled breathing and progressive muscle relaxation. Both techniques work with breathing as a way to reduce anxiety. Mindful breathing can lower your heart rate and help you relax. In a stressor response, your spleen also contracts and releases many red blood cells. This is very useful if you are injured. Although many of the dangers we see today do not represent actual physical danger, remember that our ancestors ran from wild animals to protect themselves. Red blood cells are part of the immune system and they protect us against possible infection. The liver also synthesizes and releases sugar into the bloodstream, while the bronchi dilate and increase breathing capacity in response to a greater need for oxygen. Another consequence of these chemical reactions is that the pupils dilate, allowing more light to enter the eye so that you can better see the outline of an object. The last thing the body does in response to possible danger to increase the clotting activity of the blood and increase the circulation of T cells, a type of white blood cell. The key to lowering anxiety. As you can see, there is a very clear purpose to the chemistry behind fear. The good news is that this also applies to relaxation, to all the mechanisms that activate it. In fact, the primary target of relaxation techniques is related to the parasympathetic nervous system. While the sympathetic nervous system activates the body systems, the parasympathetic nervous system lowers muscle tension and slows breathing. It also increases cardiovascular distension, which increases peripheral blood flow. The parasympathetic nervous system slows breathing, the release of adrenaline and norepinephrine from the adrenal glands, and the digestive system. The key to reducing anxiety is actually, the sympathetic and parasympathetic nervous systems cannot be active at the same time. Breathing and relaxation techniques can help deactivate one and activate the other. Fear has a psychological and biological basis. In response to a threat, the body prepares for what may happen. On the other hand, we know that it is not the threat itself, but the very perception of it, which triggers the chemical processes. Fear is not, in itself, a bad thing. The physiological mechanisms that make a stressor response possible are normal and necessary. It becomes a problem when everything is perceived as threatening, whatever it is or isn't. In this case, the body is preparing for something that is not going to happen. It's like stepping on the accelerator when the car is not in gear. You use all your energy for nothing.